Hi there, I'm Eric Miller, and I want to welcome everybody to this session here on additive manufacturing opportunities for SMEs. Unfortunately, our wonderful host, Teresa, is unable to log in right now, some local internet problems here. And so I'm going to just go ahead and get started, and hopefully she'll be able to join us soon. So again, my name is Eric Miller. Really love to welcome all of you to this discussion, and we'll learn a little bit more about what kind of opportunities are out there for additive manufacturing these days. As a little bit of an overview, the technology's been around for about 30 years. We often refer to it as 3D printing, additive manufacturing, whatever. Really started in aerospace for visual models, has grown in capability and application in almost every industry. And we're seeing a transition into tooling and now actual flight hardware out there, people making end-use parts. So my goal here is to get up to speed on where AM is, talk about some opportunities that are out there, and then share some possible next steps. And then hopefully we'll have a little bit of time for Q&A at the end. So if I click on the right screen, a few for lawyers and give some perspective, a lot of the cool stuff that I would love to share with you about how people are using this is confidential. I am a reseller of the Stratasys products. I think they're the best 3D printers on the market, but there'll be some bias in the presentation because of that. And it is very aerospace heavy because that's where we're seeing really the biggest opportunities right now. A little bit about myself. I'm the co-founder and principal of a company called PADT, which I'll talk about next. I have a mechanical engineering degree from the University of California. I graduated back in 1986 in the stone age of engineering. And at PADT, I'm in charge of basically the consulting group. I also do marketing, IT, HR, administration, and facilities. And I do a lot of speaking and writing. I love talking about 3D printing, as you will see. And I'm involved in the local Arizona startup scene as an angel investor, mentor, screening, et cetera. And last but certainly not least, in fact, one of my favorite positions that I hold is chair of the Arizona Technology Council Board of Directors. So I always do a plug. If you'd like to read more of my writing, check me out in the Phoenix Business Journal. I have a relatively regular column in there. About our company itself, we were founded back in 1994 by 4 turbomachinery engineers. We worked at the company that is now Honeywell Aerospace, was Garrett, then Allied Signal. We were using 3 evolving technologies at the time, kind of emerging technology at the time: 3-dimensional finite element analysis, numerical simulation, advanced design, 3D solid modeling, and some other techniques of how to design parts. And then what we now call 3D printing. We were using all of those to do turbine engines and thought, hey, let's start a company around those 3 things and see if they're going to take off. And we're right. These three technologies have grown immensely over the past 26 years, and we've been part of that journey. We not only provide consulting around each of those 3 things, we also do sales and support. So we're the ANSYS distributor across the Southwest, as well as the Stratasys and another code called Flownex. And you can see we're based in Tempe, Arizona, with offices across the Southwest, as well as some employees scattered further afield. We're about 85 folks. So what is our journey? A little bit of background on our journey here. We bought the first SLA 250. That was one of the first commercial 3D printing machines in Arizona that wasn't owned by a large company, and it ran one material. And we did fit and form prototypes, and the parts were brittle and slow. Then in our adolescence, we added fused deposition modeling and selective laser sintering, and we're able to run multiple materials and building functional prototypes that were stronger, and we could do it faster. And then when we really reached our adulthood on additive manufacturing, we added all these other technologies like laser powder bed fusion and polyjet and sintering and dozens of materials. And we do tooling and production parts now, as well as prototyping. And we get the properties that we want instead of getting closer, kind of, and it's much faster. And, I don't know if we've matured yet. When we get there, we hope to have more materials, more uses, that we haven't even thought of before, as well as being able to do custom properties and to turn around parts very fast. So let's go really quickly over where 3D printing is today. This is the official definition of what additive manufacturing is. And it's all manufacturing processes that make physical objects by adding material. And really, one way to think about additive or 3D printing is it's the opposite of traditional manufacturing, which is removing material, right? Or molding material. So think of it that way. And do check out the ASTM standard. There's a lot of information on this, but almost all, in fact, all 3D printing machines fit into one of these 7 categories. The inexpensive machines that you see that maybe your schools have or maybe you have at home is material extrusion, FDM and related. And of course, the thing that kind of started it all off was vat photopolymerization, stereolithography. And that's where we started our journey as well. And there's just all sorts of different ways to make parts by adding material, basically. And as I mentioned, our journey, it really started as prototypes. And this is our first machine. You see it's running DOS in the background. And stereolithography was what we used. We did a little bit of fit and then some function. It was still very valuable. This is a sprinkler head, very complicated fluids device, and built these and stuck them in the ground and tested them. Aerospace was really in the lead. Turbo machinery was a big driver. That's where we came from. And we used it to do tooling, some flight hardware. Those of you who are from Arizona, Boeing in Mesa, the helicopter group has been using SLS, selective laser sintering, for ductwork for, I think, over 15 years now, maybe more. And lots of people have just been using it in lots of different places. A lot of people don't realize that the space shuttle main engines, which are over on the right of the picture right there, are actually, parts of those are made by making a pattern using 3D printing and then a casting from that pattern instead of doing more traditional casting patterns. And then seeing more and more people using replacement parts for aging platforms, first with tooling and then flight hardware. So what's really changed over this journey is that the machines have gotten better and the materials have gotten better. That's the big change. The materials changed everything. That's really, if you walk away with one thing from this presentation that you need to know, is how important materials are in this whole thing. We have now flexible materials. We have materials with chopped fiber in them. They're high temperature. We can do metal. We can do ceramic. And then there was I forgot what I was going to say there. Polyjet. It looks like the slide is missing, which is the ability to combine materials at build time. And we're seeing more and more technologies that allow us to jet or deposit material to kind of get custom materials as we go. Also, what technology has changed? New and improved tech processes. There's better CNC welding. We're basically taking a welding machine and putting it on the end of a robot and using numerical control to build parts. Very large gantries. We'll talk a little bit more about that. The ability to sinter parts, putting multiple lasers into one machine so you can get a bigger machine or a faster machine. We'll talk a lot about post-processing and heat treating. Simulation has been a big change. We'll talk about that. And a lot of tighter controls. And we can now have industrial CT scanning so we can actually inspect these things as we go. And one thing I really like to point out in the journey that people are be aware of is kind of when it comes to doing real parts and manufacturing, is what we call the GE fuel nozzle. It was one of the first things that was approved for flight, and it was a massive cost savings. And General Electric made a huge investment in additive manufacturing to, instead of making this as a bunch of parts that were assembled by hand, a single print. And it really was the first example where you can make money making end-use parts. So I always like to shout out. You can't do a presentation on additive manufacturing without mentioning the fuel nozzle. And then we saw this kind of proliferation across aerospace. Investment in sand casting tooling, patterns for composites, rocket motors, ductwork, pressure vessels, lightweighting things, aircraft interiors. I'm going to talk a little bit about these in detail. Doing heat exchangers, impellers, turbines, and blowers, housings, just this huge explosion of end-use manufacturing using additive manufacturing. One other big improvement that's very recent is the ability to build parts without support. So when you do additive manufacturing, you almost have to hold it. There's some processes you can get away from it, but in most processes, you have to somehow either hold it against gravity or hold it from warping. And so we're kind of the dirty secret about additive manufacturing, because not only do you have to put supports in there, but you got to remove them, right? And for metal right now, there's one company, I think there's some others coming out, and maybe some of them claiming it that I'm not aware of. But the company I am very aware of is Velo 3D, and they can make a lot of parts without supports. Selective laser sintering is an older technology that's been around for a while that doesn't require supports. So supportless builds are really important. And you get there by really tightly controlling your process. And it allows us to make these crazy internal passages. Because if I have these internal passages using traditional additive manufacturing, I can't get the supports out. So big improvement there. My background actually is in simulation, so this is my favorite, and that's that we can use simulation to drive additive manufacturing now. The first is there's three areas that we do it, and I do a whole presentation, a whole class on this. But the first is drive the design. Right, we can use simulation to do these crazy topological optimization and all these really funny shapes all come out of a simulation-driven approach, generative design. And we can do it across physics, not just stress and strain. We can do it with vibration and acoustics and fluid flow and electromagnetics. And it really enables the power of additive manufacturing. Additive allows us to create any shape, or not any shape, but a lot of shapes we couldn't before. Well, what shape do I want? Use simulation to figure that out. Then we got to verify that it's actually going to work. So we come up with these crazy parts that look really cool, but are they going to work? And can we model the actual material properties that we get out of an additive part? Yep, we can do that now. And then the latest breakthrough that's really helped us is we can model the actual additive process and predict residual stresses, distortion, and then compensate and optimize the build process. So simulation's made a huge change in the industry. And then rocket motors have really kind of led the way. Some companies talk about it, some don't, but it's an ideal application in that it's high cost, complex internal geometry, and all these free form shapes for fluid flow. And you can see here a rocket engine where you've got the kind of the encapsulated internal cooling, all sorts of very neat things, all done as one build. This has been cut in half, but it's all done as one build. SpaceX is a leader in this area. They don't really talk a lot about what they do. We just know that they're doing a lot. And there's at least a dozen startups that use additive to do their rocket engines. Rocketdyne, which is now part of Pratt & Whitney, I think, or Aerojet. I can never keep it straight. But the company that used to be Rocketdyne is a longtime user of this technology. And more traditional companies are using it again and again. And you can make all sorts of cool parts on your rocket motor. So it's a great example. Ductwork is a low-hanging fruit. I mentioned the Apache earlier. We've probably done, I don't know, we probably got 10 or 15 customers that do ducts using additive manufacturing. And there's a lot of advantages to that. And replaces basically tooling and fiberglass and the fact that you have to assemble and glue things together. You just build the duct as you want it. And then a really breakthrough in using additive manufacturing that a lot of people should pay attention to is if you're in the aircraft interiors business. So now that's been certified, right? So the FAA has said, here's a pre-certified process and materials that you can use to make parts that go inside an aircraft. They're non-structural, non-structural in terms of the airframe structure, right? And it really can save a lot of time. And when Airbus talks about how many parts they have that are additive manufacturing parts on one of their aircraft, what they're really talking about are these internal things: armrest caps, seats, framework, ductwork again, wall panels, structural members in the wall panels. So we're seeing a lot of people in the aircraft interior space adopt this technology. And then we got structural polymers. So everything that we're seeing is not just metal. The Orion hatch is probably the one we talk about the most. This is, of course, a spacecraft that'll go into deep space. And we came up, Stratasys came up with an ESD-compliant polymer that's PEC-based. And the key, we helped on this project a little bit, was really the material and QA tracking, right? We knew the material would work. What we need to do is put processes in place that allowed us to let it fit within the quality system so it could fly on a spacecraft. And once the astronauts saw it, they started asking for things to be built on the space station or in the spacecraft using the same material that they could customize for their needs. And an area I'm very interested in is RF components. So surface finish is very important when it comes to antennas and things with communication, waveguides as well. But so you give up a little bit because of surface finish, but you gain a lot because you can get the geometry you really want. So you can actually get better performance, and it's all driven by simulation. So that's definitely an area of improvement that's changed the use of additive manufacturing. Another is big ass additive machines, BAMs. They're very large fused deposition modeling machines, basically a nozzle that extrudes plastic back and forth. It's an XY table. And they just made it really big and room size big. And it takes plastic that's used in injection molding. So they just basically take giant hoppers of it and melt it, put it in a large gantry. And usually because you're kind of putting a lot out at a time, you get a lot of stair steps. So you usually have a gantry CNC mill associated with it as well to kind of clean up the part as you go. And the primary use, other than making really big things and getting press about it, is making tooling for composites, right? So the example below here is the large wind turbine layup tool. So that's all made with additive manufacturing rather than machined out of a big piece of wood. Big shift that we're in the middle of right now is what some people will call high volume production. I prefer to call it higher volume production. So modifying proven technologies or introducing new technologies that allow you to make a lot of parts at the same time or make parts faster. So very exciting technology, and a lot of things going on a daily basis in this area. The thing that I recommend people pay attention to is the various continuous vat polymerizations. That's basically a stereolithography that's a consistent build or constant build. And then non-laser powder bed fusion. So taking powders and fusing them together using heat. HP's multi-jet is the best known technology in that space, and there's dozens of competitors coming out. And then binder jetting, where you kind of glue the powder together and then do something to make a final part out of it. So another thing to be aware of is you've always been able to, for many years now, you've been able to get low cost fused deposition modeling machines. Now you can get high quality, low cost machines. And that's a huge improvement, allowing, there's a lot of machines sitting in corners that are broken. So we have a Stratasys F120 in our lab, and we use it constantly. They're around $10,000, and they work really, really well. And they make functional parts that you can use for things, not just to look at. Post-processing is got critical. We don't talk about it a lot, but one of the issues with 3D printing is when the part gets done, you got to clean it or surface finish it. So there's lots of machines in that area. And then we're learning how to design for additive. And there's some really good classes out there. My favorite is the Wohlers Associates class. Do check those out if your company is looking to do design for additive. People really know how to do this now. So let's move on to the opportunities available in small and medium businesses in additive manufacturing. So the first is, don't become a general service provider. Don't buy a bunch of machines and think you're going to get people to pay you per part to make them and you're going to make money at it. There's just too many people out there. It's a shrinking market. More people are getting their own machines, so that's hurting. And then it's really dominated by the OEMs, Stratasys and 3D Systems and some other folks. There's some big players that aren't OEMs. And so it's basically become commodity with low margins. So that boat's kind of sailed. We're still in that business because we have a lot of really happy customers, so we managed to make a living at it. But if you're starting from scratch, it's going to be really hard unless you have a key differentiator. The other thing is make sure you identify a problem first. So we're on that Gartner hype curve, right? We're past it. We're kind of at the tail end of it, or coming out of the trough right now. And we did see people calling us up, which we were happy to help them with, saying, "I need a 3D printer," or management going, well, "Start making parts out of this. Stop playing around with it and start making production parts." And the thing is that there was a lot of failures along there. And this is kind of obvious, right? You shouldn't be using additive unless it solves a real problem, but sometimes it's a solution looking for a problem. So take a look at where you need it. Where is there a problem it can solve? And use additive manufacturing to differentiate. It can give some significant advantages, faster turnaround, simplify your supply chain. We're seeing a lot of interest because of COVID, people saying, how can I use additive to simplify my supply chain? And there are ways to do it. It gives you geometry freedom. So take a look at it as a way to give your company a competitive advantage. Start with that. And also, don't give up on prototyping, right? I'm talking a lot about end-use parts and tooling, but we should be doing more prototyping with additive because we've got better machines now. Make it part of the design process. Get a low-cost but robust machine. and don't make it an option. You can prototype as part of your design process. No, we're going to be using prototyping. You have to justify to management why you're not using prototyping on a project. So 4 more. Tooling is something you should really look at. If you're a manufacturer and you're not looking at how additive can be used in tooling, take a look. It's the low-hanging fruit for end-use parts, jigs, fixtures, what you need, not what you can make, right? So a lot of times we end up with tooling just because the design the way it is, because that's the only way to make it, right? Or it takes too long to make. And getting a machine shop that wants to make 2 things for you is really hard. So there's a lot of advantages to it. And my next suggestion is to do more tooling, right? Once you've done the obvious low-hanging applications, look at patterns, look at molds, look at custom jigs and fixtures, look at inserts. And so you may have a tool that you use to make something or to guide you in making something, and there's one part that needs to change a lot, or it wears out, right? 3D print that part, but the rest of it may be steel, or the rest of it may be wood, or whatever you usually use for your tooling. And also, if you're going to get into additive and you haven't gotten in there before, start with some R&D. Don't jump right into a production part or a key part, right, to your process, because there's a learning curve, right? So set aside some time and budget, pick something that doesn't impact production, a practical part that really makes a difference, and build experience and understand the processes on that part rather than on an important one. And the other thing is to look at this part count reduction. There's huge cost benefits with that. A lot of companies have moved their way from tooling into part count reduction is where they're getting their biggest savings. Look for parts that have a lot of manual assembly, right? Cost of labor is your big cost. Then take a look at low to medium volume production. We have newer technologies that allow us to make lots of parts at the same time. Find parts that have high tooling costs, really expensive tooling costs, or maybe assembly, and that you need dozens to 100. Now, we can make thousands using additive manufacturing, but the cost benefit isn't as. Once you start getting into the thousands, more traditional methods may be better. But take a look at these low and medium volume production parts as a way to leverage the technology. Also, leverage the fact that you're not constrained by how you make stuff, right? Remove those constraints. Use generative design with simulation to drive it. Don't just take your current part and 3D print it. Redesign it, taking advantage of the freedom that additive gives you. And most importantly, if you're looking to take advantage of additive manufacturing in a small business or medium-sized business, is you got to think outside the box. Identify those problems that you're having throughout your supply chain, right? Where is it? Is it in design? Is it in supply chain? Is it in inventory? Is it in customization? Where is your pain? Is it cycle time? Is it getting your tooling too late? And then see if additive is a solution to that problem. So some suggestions now. The first is don't treat additive any differently. It's just another machine. If you treat it as special, something, for a while there, people would buy an additive machine and then stick it in their lobby. And then it never got used, right? Because they wanted to show it off, right? But it just needs to be put on the shop floor right next to the other machines. You need quality tracking and inspection like any machine. And like any other technology, know your strengths and weaknesses, right? And how do you avoid the dusty machine in the corner? And there's a lot of companies out there with a dusty additive machine in the corner. First of all, buy a machine that'll last. Don't cheap out on the machine. Second, make sure it has materials that run in it that make parts that you can use. So there's some good machines out there that last a long time, but the parts can be very fragile or they melt or whatever. So pick a good material. And then make access to the machine easy, right? We just stuck our prototyping machine, and we've got 13 machines, and we weren't using additive much in our design process until I just stuck a machine into our lab and said, use it. And now it gets used all the time. And by making it easily accessible, it's been a game changer for our use of it. Make sure people know it's there as well. Educate. And take a holistic approach, right? Additive manufacturing is a tool that sits in the middle of a much longer chain, right? Look at what's upstream of it, look at what's downstream, understand materials, what material you need, how you store it, how you use it, how you verify it, quality. So take a big picture. Don't just focus on the additive side of things. And then be smart about doing things in-house. You know, how long does it take? What materials do you need? What do you use the most? What do you need to make a difference in your product? What's critical path? Figure out those things and then outsource the rest, right? So you shouldn't buy 5 different technologies. You may want to buy 1 or 2. Those are the things that most impact your business, and go with that. Outsource the rest to someone like us. Also, if you're going to be doing prototyping in-house, just make it overhead. If you charge per part, engineers go, I don't really need a prototype. I'll duct tape something together. Just make it part of overhead. Get a machine, and just put material and the amortized cost of the machine on overhead, and people will use it like you'll get the real benefit out of it. Can't stress enough the right people. This is a small portion of my additive manufacturing team. These are all outstanding experts in their field, and one of the things they're really good at is they can learn and share what they do with each other, and they love the technology. They're passionate about it. They can work across departments. You're not going to be successful without the right people. Additive is no different than any other technology. And then crawl, walk, run. We actually had companies that have gone out and bought a $1.5 million metal machine and installed it, spent another $500,000 installing it and saying, okay, let's go. That's not the way to start, right? Start with service providers. Understand the technologies by getting parts made by somebody else. Then move that key technology in-house and build a department around it. And then stay informed. This stuff changes all the time. Go to the shows, attend seminars, watch machine and materials and processes, how they change over time. So some next steps. What do we need to make the industry better? Better materials, more additive, more fiber, more digital materials, these materials that we mix on the build, and custom alloys as well. We need to get better simulation, so it's faster, kind of on the fly when we're building. True generative design, which again is a whole other topic that we can go into at some other point, and better simulation for polymer parts. Actually, it's easier to do simulation on metal than polymers. And then big effort needs to be put into post-processing. We've made a lot of progress there, but there's a reason why that person's using a brush. That right now, the only way to get the powder out is with a brush. We need to fix that. And then higher volume. Watch binder jet and sintering and more lasers in machines. And do an assessment. Take a look at your company. I want to get to questions, so I'm going to go through this really fast. But definitely sit down and take a look at how you're using AM with a multidisciplinary team and how you can do better at it. And some questions you should ask: where do your traditional geometry constraints hold you back? Where does your material hold you back? How expensive are your assemblies, processes? Would on-demand fit your business model? If you could print parts once a month rather than making a whole bunch of them once a year, is that something that would help you? Is there a place for customization? If you have an existing product and you want to customize a portion of it, is there value there? Maybe not the whole thing, maybe just a feature. And is manufacturing lead time killing your time to market, right? And so some resources put up and will be available to you. These are really oriented towards folks in Arizona, and that a professor at ASU, Drew, who's a former employee, is a great resource, and my email as well. And I think we got a little bit of time left for questions. I guess I should just read them off the chat. Or Teresa, you're back. There you are.
Yeah, I'm back. Thank you. Yeah, we do have a question here. What material do you see as next on the horizon as being a real game changer out there?
I think the next real game changer is going to be a truly a high temperature. Right now, we can only do nylon with carbon fiber in it. So I think a high temperature polymer with chopped carbon fiber in it is going to be the big game changer. So like the PEC based materials we're using right now, which are fantastic, we can get a little bit more strength, a little bit better fatigue life out of them. So once they figure out how to get the fillers in there, it's gonna change a lot of stuff. On the metal side, I'm gonna be a little more vague and say custom alloys on demand. So today I want to make this thing with these properties, and it's going to mix the powder with different materials and give you an alloy that you want.
Perfect. Excellent. Another question just popped in. What tips do you have for finding the right people with the right knowledge and skill sets? Big question.
It's a really good question, and a bigger question. The nice thing for additive is look at your local university and community colleges and find a professor that creates good students. And that's true for any industry, right? And we're lucky here in Arizona in that ASU, both at the Tempe campus and the Poly campus, have those professors. So they're graduating material scientists and mechanical engineers and aerospace engineers that know the technology. I have used it. They have machines. So find the university that's got machines where the students get to build things on the machines and learn the technology. That's your best. Other than that, you got to go through traditional channels and just try and be heard above the noise that somebody that might be looking, or find a recruiter. I'm not aware of any recruiters that know this space well. They all claim they do, but no, they don't really.
Well, thank you. Thanks so much for sharing all the information with us. We truly appreciate it. And thank you for your time.
Oh, thank you. And my email's there. If anybody has any other questions, just reach on out. I really appreciate it.
And we will put your contact information up on our website too, so folks can reach you that way as well.
Okay, great. Thanks a lot.
You're welcome.
Talk to you soon. Bye-bye.
Okay, bye.